requested, hello all, this is Buddy Craig. I'm going to try to I'm going to show you how I diagnose the first generation headlight motor circuit. Normally, I just have a feel for it. I can get in the car, hit the headlight switch a couple times, open up the bonnet, hit the switch a couple times, watch what the motor's doing, and figure out what's wrong. But if I've got one that's stumping me, this is the step-by-step logical troubleshooting process that I go through. And it really only takes maybe a half an hour. It might take me a little bit longer tonight because I'm going to be talking to you while I'm doing it. But it's really not very long of a process, and it will give you absolute positive information as to what part is failed on your system. So first thing we got to do is we've got to well, we got to start somewhere in the circuit. So let's start at the beginning. This is the isolation relay by the driver's headlight motor. There should be two 7mm bolts that hold the relay onto the inner fender well. So we're going to first I take the relay off, because it's really hard to get those wires unplugged. I've got small hands and I still have a hard time getting underneath there. So I take the relay out. I'm going to try to make sure my head doesn't get in the way. You can see what I'm doing. Usually once you get those two screws started with the ratchet, they're just finger tight. And be careful not to drop them. If you do drop them, they're probably hidden somewhere underneath the headlight. I've dropped quite a few. Okay, so I got my two screws out. Just grab the relay and start pulling up, and the wire's going to get tight. Figure out, there's two pigtails on it. There's a pigtail plugged in on this side and a pigtail plugged in on this side. Figure out which pigtail's got the tension on it. Depress the locking tab, pull up on the relay, and in theory, there the first pigtail comes loose. Then depress the locking tab on the second pigtail, or not. Okay, that one's wanting to fight. Remember, there's this black tar goo stuff inside here. That's normal. It was to help keep moisture out and keep the brass contacts and connectors from corroding. So if you see tar inside there, that's completely normal. Alright. I would normally do this with a test light. I don't recommend a multimeter for testing this, because a meter can detect 12 volts, but if the circuit can't handle any amperage, the meter can give you a possibly false positive, thinking that the circuit's good, because the multimeter will only show the 12 volts, but it can't tell you how many amps are going through it. So I normally try to use a test light for this, but I don't know how well a test light's going to show up on the video camera, so I'm going to use a buzz box instead. So we've got one pigtail with a pink wire, a blue wire with a white stripe, and a solid blue wire. So we're going to push that one to the side for a moment. The other three-way connector has got a yellow wire, a white wire, and a black wire. The black wire should always be ground, and with your headlights with your headlight switch in the off position, you should have positive 12 volts on the white wire. So that's what I'm going to test for first, is I want to make sure I've got 12 volts on the white wire. Yep, got 12 volts there. Now I'm going to turn the headlight switch on. And I should have 12 volts on the yellow wire. Okay, so as far as I know right now, my headlight switch is functioning correctly. And also, I'm assuming that I've got a good ground because I've got my jumper, my test light, or my buzz box ground plugged into the black wire of the connector. So since my buzz box went off when I tested the yellow wire and the white wire, I assume I've got a good ground. So I'm going to continue using that ground. I'm going to turn my headlights back off because the yellow wire is coming off of a fusible link, and the white wire is protected by a 12 amp circuit, or a 12 amp fuse. It's a lot easier to replace a 12 amp fuse than it is to replace a fusible link. So if I blow a 12 amp fuse, big deal. It'll take me 30 seconds to replace. If I burn out a fusible link, I'm going to kick myself in the butt because it's going to take me 15 minutes to replace that. So I'm going to take a puff of a cigarette, so hold on. Well, while I'm puffing away on my cigarette, if you did not have 12 volts on the white wire, then either your taillight fuse is blown, you've got a problem with the headlight switch, or God forbid you've got a wiring harness problem. If you didn't have 12 volts at the yellow wire when your headlight switch was on, then you've got a fuse link B as in boy, could possibly be burnt out, which I've never seen that before. I've never seen fuse link B be burnt out because of a headlight failure. I've seen it from other causes with the rest of the electrical system, but never because of a malfunction with the headlight. So if you didn't have power on the yellow wire when your headlight switch was on, you've either got a headlight switch problem, fusible link B is bad, which is down on the starter, or again, the possibility of a wiring problem, which just pray that that's not it, because you don't want to try to diagnose a wiring problem. So I'll be right back. Okay, now we're going to test the motors. We're completely circumventing the isolation relay, so remember to use the white wire. We're plugging into where the white wire is. Don't touch it against anything metal. We're going to plug it into the pink wire. That should make the motors ready. Okay. Now, well, both motors are raised, so that's a good sign. Now we're going to make one motor go down at a time. So again, we got to be plugged into the white wire. And now we want the blue with white stripe. And that's going to make the right side go down. You can't see that, but listen for it, and it should go down.